Hey everybody, welcome back to my channel. This is WireDogSec, and I'm back with another video for you guys. We are continuing on with the TryHackMe Advent to Cyber 2023 event. This is day number 16, Machine Learning Part 3. Can't capture this machine. If you're new here, be sure to hit that subscribe button with the notification bell. Hit the like button if you're enjoying the content, and comment below on your thoughts and opinion on the video, on the information shared, all that good stuff. Without further ado, let's go ahead and get into it. Learning objectives: complex neural network structures. How does a convolutional neural networks function? Using neural networks for optical character recognition. Integrating neural networks into red team tooling. Sets the machine. Be sure to read through that. I already got the machine started, as you can see here, and it starts talking about convolutional neural networks. In the previous task, we talked about neural network structures. However, most of these structures were fairly basic in nature. Today, we'll cover an interesting structure called a convolutional neural network, also known as CNN. CNNs are incredible ML structures that have the ability to extract features that can be used to train a neural network. In the previous task, we used the garbage in, garbage out principle to explain the importance of inputs having good features. This ensures that the output from the neural network is accurate, but what if we can actually have the neural network select the important features itself? This is where CNN comes into play. It says we can divide our CNN into three components: feature extraction, all right, it's important, fully connected layers, and classification. We've actually already covered the last two components in the previous task as a simple neural network structure, so our main focus for today will be on the feature extraction component. Feature extraction. CNNs are often used to classify images. While we can use them with almost any data type, images are simplest for explaining how a CNN works. This is the CAPTCHA that we are trying to crack. 4531. Since we will be using a CNN to crack CAPTCHAs, let's use a single letter in the CAPTCHA as our image. It's got the number 4 here, and it says image representation. The first question to answer is, how does the CNN actually perceive this image? The simplest way for a computer to perceive an image is as a 2D array of pixels. A pixel is the smallest area that can be measured in an image. Together, these pixels are what create the image. A pixel's value describes the color that you are seeing. There are two popular formats for pixel values: RGB. The pixel is represented by three numbers from 0 to 255. These three numbers describe the intensity of red, blue, green colors of the pixel. Grayscale. The pixel is represented by a single number from 0 to 255. 0 means the pixel is fully black, and 255 means the pixel is fully white. Any value in between is a shade of gray. To represent the image as a 2D array, we start at the loop left and capture the value of each pixel, working our way to the right in the rows before moving down. Let's take a look at what this will look like in our CAPTCHA. It's got a little example there. All right, continue on to convolution. There are two steps in the CNN feature extraction process that are performed as many times as needed. The first step is convolution. The maths is about to get slightly hectic here, so take a deep breath and let's dive in. During the convolution step of CNN's feature extraction, we want to reduce the size of the input. Images often have several thousand pixels, and while we can train a neural network to consider all of these pixels, it will be incredibly slow without really adding any additional accuracy. Therefore, we perform convolution to summarize the image. To do this, we move a kernel matrix across the entire image, etc., etc. You can read the rest there. I'm going to skim through some of this. There's a lot of information here, so be sure to check out the room and finish reading this yourself. Let's see here. As mentioned before, we can create a neural network that takes each pixel as input, but this would be an incredibly large network without improved accuracy. The summary created by the convolution process still allows us to capture the image's important details without needing all the pixels. If we calculate a feature in one location in our image, then that feature should be as useful as a feature calculated in another location image. Making use of the same kernel to determine the summary slice means this condition is met. Pooling. The second step performed in the CNN feature extract process pulling, similar to convolution. The pulling step aims to further summarize the data using a statistical method. Let's take another look at our single slice and how a max pulling will provide a summary of maximum values. You can see the little example there. I'll continue on here. Fully connected layers. Now that we've have our features, the next stage is really very similar to the basic neural network structure that we use back in introduction to machine learning task. We'll create a simple neural network that takes inputs, the summary slices from our last pulling layer, run them from the hidden layers, and then finally provide an output. This is called a fully connected layers portion of the CNN, as this is part of the neural network where each node is reconnected to all the other nodes in the next layer. Classification. Lastly, we need to talk about the classification portion of CNN. This is the output layer from the fully connected layers in the previous task. Our neural networks only had one output to determine whether or not a toy was defective, whether or not an email was a phishing email. However, to crack captures, a simple binary output won't do, as network we need the network to tell us what the character and later the sequence of characters is. Therefore, we'll need an output node for each potential character. Our capture example only contains numbers, not letters, so we need output node for 0 to 10 or 0 to 9, totaling 10 output nodes. Goes in and talks about training our CNNs. In order to crack captures, we'll have to go through the following steps, and you can see the steps there yourself. And we're going to go through and do some of this practical application piece here. I'm just going to scroll down so we get to the questions areas. We're going to do all this here in a second. All right. All right. If you have not read through all this, be sure to do that before you start answering questions down here. So we're going to take a look at the questions real quick. What key process of training a neural network is taken by the CNN? As we saw up above, feature extraction, right? It was highly mentioned. And then what is the name of the process used in the CNN to extract the feature? That's convolution, and we already talked about that earlier. What is the name of the process used to reduce the features down? I was pulling, as discussed above. Again, we went over that. What off-the-shelf CNN did we use to train the captchas, cracking our OCR model? You'll see that as you read through. It's going to be attention OCR, and we're going to get to the practical option or practical application portion. So let's go back up. So steps 1 to 4 are quite taxing, so they've already been done. We'll do a quick recap of these steps involved before moving on to the hosting the model and cracking some captchas. To this, you have to start the Docker container, internal window, executing the command, which I've already done apparently. This will start a Docker container that has TensorFlow and AOCR already installed for you. You will need to connect to this container for the next few steps. First, you'll need to find the container's ID by using the following commands. Let's go ahead and do that. Docker ps. All right. It says take note of your container's ID and run the following command. So let's do that. So docker exec, and then where's that at? Container ID. All right. So go ahead and copy that. All right. And then bin bash. Awesome. Okay. This will connect you to the container. You can now navigate to the following directory. So let's go ahead and do that. CD into this directory here, OCR. Awesome. Gathering training data. In order to train our captures, cracking CNN, we first have to create a data set that can be used for training. Let's take a look at the authentication portal for the HQ admin. Open following link in the browser window in the VM, and you'll see the following authentication page. So let's go ahead and do that. I'm just going to copy this and paste it into Firefox over here. Okay, let's see here. I'm going to go ahead and scroll down here to get ready for the next step. This is going a little bit slow. All right, any day now. Here we go. Okay, awesome. Oh, okay, guess it's already there. Well, that's good. As we can see, the authentication portal embeds a capture image. We can get the raw image using a simple curl command from the normal terminal window. So let's go ahead and do that. Copy and paste again. Back to terminal. Oop. Let me just close this out and go back to the one I already have open. Make it a lot easier. All right. So go ahead and paste this in there. It says in the output, cannot resolve. Weird. Okay. Let's try a new tab and do it again. There we go. Okay. In output, you'll see the base64 encoded version of the CAPTCHA. We can write a script that will download this image and then prompt us to provide the answer for the CAPTCHA. To store training data set, that's already been done for you. You can view the stored data using the following command in the Docker container. So let's go ahead and do that. The base64 stuff. There we go, right here. This, I guess it's this huge thing here, this huge blob here. Yeah. Yep. Creates CAPTCHA. Awesome. So let's go back over here and paste this in. Okay, for some reason it didn't copy over, so let's try this again. All right. All right, while that's running, let's continue on. Creating the training data set. Next, we need to create the training data set in a format that AOCR can use. This requires us to create a simple text file that lists the path of each CAPTCHA and the correct answer. A script was used to create this text file and can be found under labeling directory. You can use the following command to view the text file that was created. So let's go ahead and do that. Copy and paste again. Awesome. You can see all the information there. Just once we have our text file, it has to be converted into a TensorFlow record that can be used for training. This has already been done for you, but you can use the following command to create the data set. So let's just go ahead and do it just to see what it looks like, I guess. All right. Paste this in there. Oh, well, that's loading. As mentioned before, this has already been done for you and stored in labels directory. We have created two data sets, one for training, one for testing. As mentioned in the introduction, day 14, we need fresh data, yada, yada, yada. Training and testing CNN. So we're going to go here, see if this finishes running. Actually, I'm just going to, okay, great. No such file. All right, weird. Anyway, let's see if we can just navigate to this area. If it copies. Let's try this again. So the stuff's already been made, so maybe that's why it like aired out. But I guess we'll find out here. All right. It's not compiled to, okay. Training will not begin once the training has complete. A couple of steps. Stop by Control C. Let's take a look at one of the output lines from the running the training, and it's got it displayed out there. In each of these steps, CNN is trained on all inputs, similar to what was discussed in the introductory to machine learning task. Each image is given an input to the CNN, which will then make a prediction on the numbers that are present in the CAPTCHA. We will provide feedback to the CNN on how accurate its predictions are. The process is performed for each image in our training dataset. To complete one step of training, the output for AOCR shows us how long it took to perform the round of training and provides feedback on the loss and perplexity values. Loss, you see that there, and perplexity, you can read that there. So be sure to read these to understand what's going on. As the CNN has already been trained for you, you can now test the CNN by running this. So I'm going to kill this and then run this. Okay, let me make sure it's lets me out of here. I take a little bit. There we go. All right, so let's go ahead and do this here. Okay. Testing will now begin. Once a couple of tests are complete, you can stop it once again using Control C. Let's take a look at the two lines here. So just actually 100% loss, perplexity, probabilities, etc., etc. All right, so let's go ahead and kill it. Okay. Pretty much the same thing here. So as you can see from the testing time, running a single image sample through the CNN is significantly faster than training it on the entire data set. This is one of the true advantages of the neural networks. Once training has been completed, the network is usually quick to provide a prediction. As we can see from the predictions provided at the end of the lines, one of the CAPTCHA predictions was completed correctly, whereas another was a prediction error, mistaking a 5 for a 6. If you compare the loss and perplexity values of the two samples, you will see that the CNN is uncertain about its answer. We can actually use this to our advantage when performing live predictions. We can create a discrepancy between captcha prediction accuracy and captcha submission accuracy simply by not submitting the captchas that we are too uncertain about, etc., etc. You can see the rest there. Hosting our CNN model. Now that we've trained our CNN, we'll need to host the CNN model to send it captchas through the brute forcing script. For this, we'll use the TensorFlow serving. All right, so let's see here. Once the CNN has been trained, we can export the weights of the different nodes. This allows us to recreate the trained network anytime. An export of the trained CNN has already been created for you. Awesome. OCR model directory will now export that model from the Docker and use the following command. So let's go ahead and do that here. So copy and paste this over. All right, I'm just going to try to clear this out to make it a lot easier to read. Okay, let's do this. Now, while that's loading, once that's complete, you can exit the Docker container terminal, use the exit command, and kill it using the following command. You can reuse Docker PS to get the container ID, Docker killed, and then container ID. So let's go ahead and do that. Let's see, Docker, let's use exit, and then Docker PS. So let's go ahead and kill it. All right. So Docker kill and the ID. All right. TensorFlow serving will run in a Docker container. This container will then expose an API that we can use to um, with the hosted model to send it a captcha for a prediction. You can start the server containing using the following command. So let's go ahead and do that. All right. So copy paste again. This will start a new hosting of the OCR file that was exported for the AOCR training Docker container. We can connect to the model through the API hosted on this link here. So let's go ahead and just copy this. All right, now that we're finally ready to help McSkitty regain access to the HQ admin portal, brute forcing the admin portal. We're now ready for our brute force attack. You've been provided the custom script it will use. You can find the custom script and password list on the desktop in the brute force folder. Let's take a look at the script. All right, so be sure to read through this here. All right, we're going to continue on here. Let's dive into what the script is doing. First, we load the libraries that will be used. We'll mainly make use of Python's request library. Next, we'll load our password list in the loop. We'll perform brute forcing attack, yada, yada, yada. You can see the rest there. Let's run our brute force attack using the following command in a terminal window. So we're going to copy and paste that over. Let it run for a minute or two, and we'll gain access to the portal. Okay, so let's go ahead and do that. All right, now we're ready. Go ahead and fire it off, and it's going to go through and start doing its brute force attack against this particular website and try to find the correct username and password combination. All right, this is actually pretty neat here, and it found it relatively quickly. Username's admin, and password is really not going to guess this, which is going to be the answer to this question here. What is the password that McGreedy set on HQ portal? Now it's time to get the flag, so we're going to copy this password here out of here. All right, and we're just going to refresh the page. All right, paste this password in there, and then put in the CAPTCHA 26690. All right, and there we go. That's the flag. And that's going to be the answer to that last question there. It says, if you enjoyed this room, check out our red teaming learning path. So be sure to check out the red teaming learning path if this caught your interest. I think we'll start seeing a lot more of this in the future. Like I said in a different video, this AI stuff, machine learning stuff is going to be more and more prevalent when it comes to adversaries' attacks and also in cyber defense. We're going to use this to our advantage. So be sure you learn and understand what's going on here. As always, if you're new here, be sure to hit that like button with the notification bell. Hit the like button if you enjoyed the content. Comment below on your thoughts and opinions. Thank you for watching. Have a nice day, and I will see you later.